The world of cryptocurrency promises decentralization and financial freedom, but it also harbors hidden dangers that can shatter this illusion in an instant. One such threat, the infinite mint attack, can cripple a cryptocurrency project, leaving investors devastated and the entire ecosystem shaken. Imagine a rogue actor gaining access to the printing press of a digital currency, creating an endless supply of tokens out of thin air. This is precisely what transpired with the paid network in 2021, a stark reminder of the vulnerability of even seemingly secure blockchain projects. The paid network, a platform designed to facilitate business agreements on the blockchain, fell victim to an infinite mint attack that sent shockwaves through the crypto community. Hackers exploited a vulnerability in their smart contract, allowing them to generate and steal millions of paid tokens. The consequences were disastrous. The token's value plummeted by over 90%, wiping out millions in investor funds and severely damaging the project's reputation. This incident serves as a stark reminder of the critical importance of robust security measures in the world of decentralized finance. The paid network attack highlights the fragility of trust in the crypto ecosystem. When a project falls victim to such an attack, it erodes confidence in the entire space. Investors become wary, developers face heightened scrutiny, and the dream of a decentralized future seems a distant reality. The incident serves as a wake-up call, urging developers and investors alike to prioritize security and vigilance in equal measure. This essay delves into the intricacies of infinite mint attacks, exploring their mechanics, examining real-world examples, and outlining crucial steps to mitigate these risks. At its core, an infinite mint attack is a type of exploit that targets the fundamental mechanism of cryptocurrency creation. Most cryptocurrencies rely on a predetermined supply, ensuring scarcity and value. This supply is governed by a set of rules embedded in the project's smart contract, a piece of code deployed on the blockchain that automatically executes transactions and enforces the rules of the cryptocurrency. Hackers exploit vulnerabilities in these smart contracts, effectively hijacking the minting process to generate an unlimited number of tokens. Imagine a hacker finding a backdoor in the code that allows them to bypass the limitations on token creation. They gain the ability to mint new tokens at will, flooding the market with worthless currency. This sudden influx of supply drastically devalues the existing tokens, leading to a rapid price crash. The attackers then dump their ill-gotten gains on the open market, maximizing their profits while leaving legitimate investors holding the bag. The success of an infinite mint attack hinges on the attacker's ability to identify and manipulate vulnerabilities within a project's smart contract. These vulnerabilities can arise from coding errors, design flaws, or inadequate security audits. Once a vulnerability is identified, the attacker can craft a malicious transaction that exploits the weakness, granting them unauthorized access to the minting mechanism. The complexity of these attacks varies, but the underlying principle remains the same: exploiting weaknesses to gain control over token creation. The world of smart contracts, while revolutionary, is still in its infancy. As with any nascent technology, vulnerabilities exist, and hackers are constantly searching for ways to exploit them. In the context of infinite mint attacks, these vulnerabilities often stem from coding errors or logic flaws within the smart contract. For instance, a contract might have insufficient input validation, allowing an attacker to manipulate the amount of tokens being minted. Another common vulnerability is the reentrancy attack, where a malicious contract interacts with a vulnerable contract multiple times before the initial transaction is completed. This allows the attacker to repeatedly execute a function that mints tokens, essentially draining the supply. Such attacks highlight the importance of rigorous testing and auditing of smart contracts before deployment. Hackers employ various techniques to uncover these vulnerabilities. They might manually review the code, use automated tools to scan for weaknesses, or participate in bug bounty programs where developers offer rewards for identifying security flaws. Once a vulnerability is identified, the attacker can craft a malicious transaction that triggers the exploit, granting them control over the minting process. The ingenuity and persistence of these attackers underscore the need for constant vigilance and proactive security measures in the crypto space.